Okay, in this video, we are discussing the in-text question related to depression and freezing point. 2.11, calculate the mass of ascorbic acid, vitamin C, C6H8O6, to be dissolved in 75 grams of acetic acid to lower its melting point by 1.5 Celsius. Kf is 3.9 Kelvin kilogram per mole. For the sake of, I tried to look up and try and find out why it was in Celsius, could not find anything. I'm just going to assume that, like, how we did it the previous question, where essentially, since both the values are getting subtracted with each other, I'm going to assume that the original melting point and the melting point of the solvent in the solution are subtracted and they're in Kelvin. And then essentially that implies that this is going to be in Kelvin. And that's what helped me. So delta TF is equal to 1.5 Kelvin. And yes, I will consider it to be in Kelvin because if not, the units are not going to get cancelled. And then we have KF equals to 3.9 Kelvin kilogram per mole. And this is essentially what we had in the previous question as well. Like the only difference here is that they've given us the value of delta TF in the previous one. We had to calculate the change in temperature. That was boiling point and this is the freezing point. That's the differences. And then we've been given the mass of um, of acetic acid, which is going to be our solvent. So I'm just going to say W1 is 75 grams. Okay, now we can obviously use the exact same equation, but we'll be using the depression and freezing points. M2 equals to Kf into W2 into 1000 whole divided by delta Tf into W1. So we need to find out the value of W2. We have the value of everything else but this, and we can easily calculate the value of M2. So M2, the molecular formula of ascorbic acid is C6H8. Oh my God, I'm sitting so far from the screen. C6H8O6, and we can basically use this to calculate the molar mass. So 12 into 6 plus 8 into, actually I should have not done that, sorry. So 1 into 8. If it's not obvious, I try to keep it consistent where you have either the mass on the outside or the number of atoms, whichever. I know I change it sometimes. I mean, I literally never follow a particular way of writing it, but I always make sure they're consistent in that equation at least. So 16 into 6. And this will give us 72 plus 8 plus 96. That is equal to 176 grams per mole. Now we can just use this equation. So W2 will be equal to delta TF into M1, M2 into W1 whole divided by KF into 1000. So that's equal to delta, let's write delta TF 1.5 Kelvin into M2, which is 176 grams per mole into W1, 75 grams whole divided by Kf, which is 3.9 Kelvin kilogram per mole into into 1000, right? Okay, almost there. Into 1000. And yes, if you notice Kelvin and Kelvin, you can cancel it. If it was Celsius, you would not have been able to. I'm just assuming that the units are either this was supposed to be in Kelvin, or I'm just going to assume that both the other ones that was like this was calculated using were in Kelvin, and then we got this value in Kelvin. So, or you could just ignore all the units and put them in the end. I just feel like that's wrong. So, oh, grams per kilograms. Um, per mole gets cancelled. Oh, wait. Oh, yeah, we have grams and grams. So we have one unit with grams in it. And then this on simplification gives us 19800 on the numerator divided by, sorry, divided by 3.9 into 1000 grams. And this on further simplification gives us 5.0769 grams. So essentially 5.0769 grams of ascorbic acid needs to be added in 75 grams of acetic acid to lower the melting point of acetic acid by 1.5 degrees Celsius or 1.5 Kelvin. Again, I'm just assuming that that's the case. If you have a justification for that, let me know and we can talk about it. So essentially, we just use the same thing we did in the previous question. We use the formula of molar mass using the depression of freezing point, and we know the value. We were able to calculate the value of M2 using the formula of ascorbic acid, and then we had to calculate the mass of ascorbic acid using the equation, and that is exactly what we did. In the next video, we will be doing question number 2.12.